This is going to be short. We should be in and out probably 3 to 5 minutes, probably 5 minutes. I don't know. Reporting the results from repeated measures. I would probably go with something like, first of all, let's report the results from Mauchly's. So we would say Mauchly's test for sphericity indicates, or indicated, we'll do it in past tense, that the assumption is violated. And I think our W was 0.13. Let me just double check that. So Mauchly's 0.13, p-value less than 0.05. Okay. Therefore, the degrees of freedom were corrected using Greenhouse-Geiser estimates of sphericity. And here, I think our epsilon's 0.56 for sphericity. Yeah. So Greenhouse-Geiser 0.56 for epsilon. So we've got to work a little bit here. Let me just go ahead and show you this. We go to Insert, go down to Symbol, go to Symbol Browser, and go to our Greek alphabet, and there's epsilon. Copy it, close it down, paste it. Now, it'll enter that in some, or paste that in some wacky typeset. I'm not even going to worry about that now. I'll come back and get all that later. So that was 0.56. That's going to drive me crazy. Can't handle that. So let's get this all back into the original typeset. All right. Okay, so we would say, so using Greenhouse-Geiser, we have a p-value, let's see, which was above 0.05, so we don't have statistical significance. And I think in the video I actually made a mistake, because I actually went ahead and ran the model assuming sphericity. And the whole purpose of the video was to show you that we had violated sphericity. So there at the end, I told you that we had statistical significance, but we didn't. We didn't have it because the sphericity assumption was violated. If sphericity hadn't been violated, then what I did at the end of the video would be fine. So anyway, correcting that right now. So we could say that the results show that the grading of the problem was not statistically significant. Well, let's say not statistically significant, not statistically affected by the grader, by the tutor. By the tutor. All right. Now, here's a situation where, right up here we talk about the degrees of freedom were corrected. Now, if we run our model like we did the other time, our degrees of freedom, remember, were 3 and 21. But that's not what we're using here. We're using the degrees of freedom correction for the Greenhouse-Geiser. Guys, the first, let me jump down here. The first degrees of freedom that you'll put in here will be the epsilon times k minus 1. So guys, in our situation, this is going to be 0.56 times, there were 4 tutors, so this will be times 3. So this is 1.68. And the next degrees of freedom will be the epsilon times k minus 1 times n minus 1. Now notice that's not cap n, so it's not the total sample size. This would be the let me go back over here. This would be the problem. So looks like we're going to have here, we're going to have 0.56 times 3 times 7. So 11.76. And our value is 3.70, right? And our p-value was equal to 0.063. Now, this value right here, the 3.70, isn't given to us in the output. But what you could do, I mean, it's kind of like degrees of freedom. You know, well, it's kind of like if I know that if I have 4 numbers and 3 of them add up to 20, and I know 2 of the numbers are 2 and 5, then I know the other has to be 13. That's kind of what I got here. I've got my degrees of freedom, 1.68 and 11.76. I know that my p-value is 0.063, so I could use QF, which is something we've seen before in R, to come up with that. And that's the way I did that earlier. And then our generalized eta squared. Was what? 0.32. All right, gang, let's just correct some typeset, and this is what you'll be expected to be able to present something like this. I'm not saying that the assumption will be violated or it won't, but something to that effect. All right, guys, that does it, thankfully.